Chapter 21. Out of the Past, the Future. Sending a man into space was a tall order, but it was the part about returning him safely to Earth that kept Katherine Johnson and the rest of the Langley employees awake at night. There were countless ways that things could go wrong, and they needed to be ready for each one. The rocket had to operate flawlessly. The Atlas rocket was going to be used to take the Mercury capsule into orbit, but it was temperamental. 2 of its 5 previous launches had ended in failure. One rocket had surged into the sky, then exploded mid-air. There seemed to be an infinite number of things that could go wrong with the spacecraft. The space capsule itself was a sophisticated tin can, but one that required elaborate engineering. The vehicle's oxygen and pressurization systems were all that stood between the life-crushing vacuum of space and the person riding inside. If the capsule wasn't strong enough to withstand the intense forces of the launch, it would explode. Every wire, every switch, every gauge, every component had to be tested and retested to make sure that it worked flawlessly. Success depended on the engineer's mastery of the laws of physics and mathematics. The spacecraft demanded extreme precision and accuracy. Even a simple error would have catastrophic consequences. There seemed to be an infinite number of ways that could go wrong. Infinite ways things could go wrong, and only one way to get it right. America's astronaut. Nobody understood the risks of spaceflight better than astronaut John Glenn. The former U.S. Marine Corps test pilot had been chosen as the astronaut for America's first orbital flight. He pushed his body to the physical limit to prepare for the mission, and he worked tirelessly on the simulators and trainers, preparing for every failure scenario the engineers could imagine. He knew that his life depended on his readiness. As a test pilot, Glenn knew that the only way to remove all risk was to cancel the mission. He understood that he was likely to encounter some unforeseen problems, so he did his best to be ready for them. The preparations took longer than expected, and Project Mercury's launch was pushed back from late 1960 to July 1961, and then to 1962. The Russians didn't slow down. In August 1961, they completed a 7-orbit flight, nearly a full day in space. The Soviet successes put even more pressure on NASA to get the mission off the ground. In addition to the technical challenges, the launch team had to deal with the weather. Overcast skies at Cape Canaveral, Florida, delayed takeoff on 2 more dates. Finally, the date was set, February 20th, 1962. John Glenn handled the delays with patience and grace. He stayed in top condition and remained focused. Before taking off, he asked the engineers to complete one more check. He asked them to double-check the math that had been done by the electronic computers. Many of the astronauts didn't fully trust the electronic number cruncher machines. As former test pilots, they staked their reputations and their lives on maintaining constant and direct control over their planes. A tiny error in judgment or a second of delay could mean disaster. The Mercury mission linked the spacecraft with the electronic computers on the ground. The astronauts worried. What if the computer lost power or seized up during the flight? When the Space Task Group bought more powerful computers, the trajectory equations were programmed into the machines so that they could automatically guide and control the rocket and send information about the capsule's position back to mission control. If the rocket misfired and sent the capsule into an incorrect orbit, the computer would alert the flight controllers who had the power to abort the mission. The capsule would detach from the rocket and land safely in the sea where the astronaut could be rescued. Once successfully launched, the capsule would push through the atmosphere and settle into orbit. It would separate from the rocket and establish new communications connections with the ground stations. The spacecraft would send data back to the tracking stations, which would capture the signals with their 64-foot receiving dishes. The Goddard Space Center in Maryland would also send Mission Control in Texas data about the spaceship's position. Hovering over the giant map of the world at Mission Control was a little cutout of a Mercury capsule, suspended on a wire. As data came into Mission Control, the image of the capsule would move across the map. While it was an unsophisticated map by today's standards, at the time, it helped the engineers follow the flight path. The capsule's signal would bounce from one tracking station to another as it moved. The data would allow the controllers to ask, where was the capsule compared to where they had calculated it to be at a given time? Was it too high, too low, too slow, too fast? They would constantly refine their data and make adjustments. This information would be used to determine exactly when the capsule's rockets should fire to bring the spacecraft back to Earth. For the mission to succeed, the hardware, the software, and the human beings had to function properly. A breakdown in any component would be tragic, and it would all unfold on live television. The human computers crunching numbers were something the astronauts understood and trusted. The women mathematicians dominated their mechanical calculators, the same way the test pilots dominated their planes. Spaceship flying computers might be the future, but John Glenn didn't have to trust them. He did trust the human computer, Katherine Johnson. "Get the girl to check the numbers," Glenn said. If Katherine Johnson and the numbers were good, he was ready to go. Countdown. The space age and the television age were coming into their own at the same time. NASA understood that they were making history and that the events taking place should broadcast to the world and recorded for history. The agency sent a film crew to each of the tracking stations, recording the communications teams as they completed their pre-flight checkouts. The footage showed the second-by-second drama in mission control as white men in white shirts and black ties faced long desks with communications consoles, headphones on, serious expressions on their faces. The men stared up at an enormous electronic map of the world on the wall in front of them. Because of her close working relationship with pioneers of the Space Task Group, it was Katherine Johnson who found herself in a position to make the most immediate contribution to the Mercury mission. When the phone call came in to Katherine Johnson's office at Langley, she was sitting at her desk. She overheard the call with the engineer who picked up. She knew she was the girl being discussed in the phone conversation. Astronaut John Glenn didn't know her name, but she was the one he was talking about when he wanted someone to double-check the numbers. Katherine knew the numbers he meant, the ones that described the trajectories of an orbital mission around Earth. Just like her first research report, the one she had worked on with the engineer Ted Skopinski, in the final section of the report, Katherine had calculated by hand 2 different sample orbits, plugging numbers into the equations in the report. Then she compared her results to the results from the IBM electronic computer, which had been programmed to calculate the same equations. At the time, it turned out there was very good agreement between the IBM's output and Katherine's calculations. Katherine and the machine got the same numbers. This work, double-checking the electronic computer, was a dress rehearsal for the work that was now required, checking the numbers not for a sample orbit, but for a real mission, with an astronaut on board. Confidence. Though Katherine Johnson didn't usually panic in stressful situations, she was very nervous about the task in front of her. But she was confident in her math skills, so she organized herself at her desk. Thick stacks of data, sheets, and trajectory equations surrounded her workspace. Instead of generating numbers and sending them to be checked by the computer, Katherine worked in reverse. She took the data from the computer and ran it through her own calculations. She wanted to see very good agreement between her numbers and those generated by the computer. Katherine worked through every minute of a 3-orbit mission. It took a day and a half of watching the numbers pile up until she had completed the task. When she delivered the data sheets to the Project Mercury engineer, she had no doubt that her numbers were correct. February 20th, 1962. Dawned bright and clear, and 135 million people tuned in to watch the launch unfold on live television. Katherine Johnson sat in the office breathlessly watching the news coverage. At 9:47 a.m. Eastern Standard Time, the Atlas rocket boosted Friendship 7 into orbit. Ground control cleared John Glenn for 7 orbits around Earth. During the first orbit, the capsule's automatic control system began to act up, causing the capsule to pull back and forth like a badly aligned car. Glenn smoothed it out by switching the system to manual and acting as if he were flying a plane. At the end of the second orbit, a warning light indicated that the heat shield was loose. A heat shield is the outer covering on a spacecraft that protects it from extreme heat when the craft re-enters Earth's atmosphere. Without that firewall, there was nothing standing between Glenn and the 3,000-degree temperatures, almost as hot as the surface of the sun. That would build up around the capsule as it passed back into Earth's atmosphere. Mission Control had a solution. At the end of the third orbit, after the retro rockets fired, Glenn was to keep the rocket pack attached to the spacecraft instead of getting rid of it, as was standard procedure. The NASA engineers hoped that the rocket would keep the loose heat shield in place. At 4 hours and 33 minutes into the flight, the rockets fired. John Glenn adjusted the capsule to the correct position and waited. The spaceship slowed down and pulled out of its orbit, heading down. At that point, the most dangerous part of the re-entry. The signals flickered, then went silent. There was no signal from Friendship 7. The engineers tried to figure out what had gone wrong, but there was nothing mission control could do. Silence. 1 minute passed. Then 2. 3. Everyone feared the worst, that the heat shield had failed and that the spacecraft had been burned. The team struggled to reconnect with the spacecraft. 10 minutes passed. 11. 12. 13. 14 minutes after the signal silenced, John Glenn's voice returned. He was alive. The spaceship continued its descent, with the computer predicting a perfect landing. When Friendship 7 splashed down, it was off target by just 40 miles, and that minor error was only because the estimated weight of the capsule during re-entry included the added weight of the rocket that had remained in place. The computers, both electronic and human, had worked flawlessly. 21 minutes after landing, astronaut John Glenn was safely out of the water. John Glenn was a hero. He had an audience with the president, a ticker tape parade in New York, and, from Maine to Moscow, large newspaper headlines cheering him. The African-American press cheered him. All of us are happy to call him our ace of space, wrote an African-American columnist in the Pittsburgh Courier. Nowhere was the hero's welcome as warm as in Hampton Roads, Virginia. 30,000 local residents turned out in mid-March to celebrate the man they considered their hometown hero. Glenn rode in the lead vehicle of a 50-car parade that included the Mercury astronauts and their families. The 22-mile route went through Hampton and Newport News. The parade ended at a stadium where Glenn stood behind a podium with a sign reading, Spacetown, USA. The city of Hampton changed its official seal to depict a crab holding a Mercury capsule in its claw. It adopted the motto, E Praeritis Futura, out of the past. The future! John Glenn wasn't the only one being cheered. Word of Katherine Johnson's role in the mission made the rounds in the African-American community. On March 10, 1962, a photograph of Katherine Johnson was featured on the front page of the Pittsburgh Courier. The caption read, "Her name, in case you haven't already guessed it, is Katherine Johnson. Mother, wife, career woman." The article recounted Katherine's contributions to the work that sent Glenn's rocket through the sky. Johnson attended the Hampton parade, allowing herself just a moment of pride at having been part of such an accomplishment. She didn't stay too long. She wanted to recognize the hard work and success of the team, but there was nothing more exhilarating for her than getting back to work on the next assignment.